What if I told you there's an asteroid the size of a 15-story building, and at one point scientists thought it had a real chance of slamming into Earth? Asteroid 2024 YR4 lit up risk charts earlier this year, and headlines panicked a minute. But here's what most people missed. Predicting asteroid impacts is way more complex than just spotting a rock in space. So, how do scientists actually calculate if an asteroid will hit us? And how does NASA use systems like Sentry, Atlas, and even the James Webb Telescope to protect Earth? Let's break it all down. And trust me, by the end of this video, you'll look at space lots a little different. First up, astrometry. That's just a fancy word for measuring where space rock is and where it's going. Telescopes like the ESO's Very Large Telescope track asteroids by 2024 YR49 after. These observations let NASA calculate asteroids in its speed, direction, and how it's pulled by the gravity of planets or even other asteroids. But here's the twist. Early on, the data is very rough. There's always a margin of error. Scientists visualize this uncertainty as an error ellipse, a kind of blob in space where the asteroid might be in the future. And if any part of that blob crosses Earth's orbit, there's a chance of impact. That's where impact probabilities come in. For example, in February 2025, asteroid 2024 YR4 had a 3.1% chance of hitting Earth in 2032. That sounds scary, but it just means that 3 out of 100 potential orbits hit us, and 97 miss completely. Now here's where NASA's Sentry system changes the game. Sentry is a fully automated impact prediction system, running 24/7 from NASA's Jet Propulsion. It checks the orbits of every known near-Earth object, thousands of them, scans their future paths up to 100 years. So what did Sentry see for 2024 YR4? On December 27, 2024, it was spotted by the Atlas telescope in Chile. Just days later, Sentry gave it a 1.2% chance of hitting. That risk peaked at 3.1% in mid-February 2025, before quickly dropping to almost nothing, less than 0.0000%. IG. How? Because each new observation helps narrow the asteroid's path. The more you observe, the smaller the error ellipse gets, like sharpening a blurry photo. Here's the twist no one saw coming. Even as Earth got safer, the moon became a new target. By April 2025, scientists gave asteroid 2024 YR4 a 3.8% chance of hitting the moon. Now that might not sound like a big deal, but it raises interesting questions. Could debris from a lunar impact reach Earth? Technically, yes, but our atmosphere would burn up most of it. So don't expect a sci-fi apocalypse from lunar ejecta. Still, it shows how complex and dynamic these risks are. The tech behind all this is insane. Beyond Sentry, NASA uses Atlas. It scans the entire night sky for moving objects, capable of spotting small asteroids days before. JWST, yes, the James Webb Space Telescope helped refine YR4's size and signature, using infrared vision. Scout, a quick response system that evaluates immediate threats even before Sentry processes them. And soon, the INEO Surveyor, a powerful infrared space telescope launching in 2027, which will fill gaps when asteroids get too faint for ground-based scopes. Add to that international collaboration. NASA works with ESA, Japan Space Agency, and the International Asteroid Warning Network. They even held emergency meetings about YR4 in early 2025, just in case. Here's the real issue: public panic. YR4's risk jumped from 1.2% to 3.1%, then dropped to 0 in just weeks. Headlines scream doomsday, and then silence. That's why scientists are now debating. Should they wait before going public with early data? Or is total transparency better? NASA argues that early warnings are necessary, but with better context. A 3% risk, limited data, isn't the same as a 3% chance. Clear communication could prevent unnecessary and build trust in science. So, what do we learn from Asteroid 2024? Early risk doesn't mean danger. More data always brings clarity. And behind the scenes, NASA's using mind-blowing tech to watch our skies. If you found this fascinating, hit like, subscribe, and let me know in the comments. Should NASA delay asteroid alerts until the risk is better understood? Or do we deserve to know immediately? Even if it's uncertain, stay curious. And I'll see you in the next deep dive into the science that protects our future.